So, right, welcome to Inorganic Tutor channel. Please don't forget to subscribe as well as share to your friends to also benefit from this lesson. All right. So today we want to look at how to prove that root 2 is a rational number. You already know that root 2 is an irrational number, right? But we want to use this course, abstract algebra, a course that can tell you that prove that 1 plus 1 is equal to 3. So it's not weird or it's not strange that we want to prove that root 2 is a rational number. All right. So first of all, what you must know or what you must do is that if you want to show that or prove that root 2 is a rational number, you have to show that or prove that root 2 is a rational number. We need to show that it can be expressed as the ratio of two integers. All right. So the ratio of two integers, that's p and q. All right. Where q is not equal to 0. You know that when q is equal to 0, you are going to have an undefined function or an undefined expression. So let's assume that root 2 is a rational number. Or let's assume that root 2 is rational. So we can write it in the form as p over q, where p and q are integers. All right. If you're able to write this, but don't forget that p over q, and we say q should not be equal to 0. All right. You know that the reason is always clear that if q is equal to 0, you're going to have an undefined expression and you can't work with that. All right. So that is fantastic. But let's look at the next. So from there, where this p and q are integers with no common factors other than 1. All right. If you want to show that root 2 is a rational number, first p and q must be integers where q is not equal to 0. All right. And then the integers must not have any factors except or other than 1. All right. So from there we can say that root 2 is equal to p over what? Q. All right. So from here we can say squaring both sides. All right. So squaring both sides, we have root 2 squared is equal to p over q all squared. All right. So this we have 2. You know that root 2 squared will give you what? 2, which is equal to this p squared over q squared. All right. So from here we can say that we have 2q squared is equal to p squared. All right. Very, very clear. So from here we can say that p is even, and if p is even, p squared is even, and p must also be even. All right. So that is very simple. If p squared is even, then p must also be even. All right. So from here we say that, or we can say that this should be equation 1. All right. So from there, we say let P equals 2K. Alright, we let P equals any value or variable with a constant. Alright, so P equals 2K, and then we put in, let's say this is equation 2. Alright, so putting equation 2 into equation 1, we say 2K squared is equal to 2K. Alright, 2K squared is equal to 2K. Alright, so from here we can say that if you want Q, then all you have to do is that you can say from here, you can say that we have 2K all squared. Alright, so we have 2K squared is equal to 4K squared. Alright, so from here we can divide by 2. Alright, and then we have Q squared is equal to 2K squared. Very, very nice. So from here we can also say that Q squared is even. Alright, if Q squared is even, then Q must also be even. Alright, if Q squared is even, then Q must also be even. Alright, so from there we can say that if both P and Q are even, if both P and Q are even, then they have, if both P and Q are even, then they have a common factor of 2. Alright, if both P and Q are even, then we can say that they have a common factor of 2. So from there, we can say that from our previous or from our initial assumption, we can say that this contradicts the initial assumption that root 2 is a rational number. Alright, this contradicts the initial assumption that or we can also say that this contradicts the assumption that P and Q have no common factors. Other than 1. Alright, so from here we can see that since P and Q are even, then they have a common factor of 2. Alright, so if this is true, then our initial assumption that P and Q have no common factors other than 1 is not true. Alright, so therefore the initial assumption that root 2 is rational must be forced. That's root 2 is an irrational number. Alright? That's root 2 is an irrational number, not rational. Alright? Hence, proving as required. Alright, so this is basically how we go about such a problem or proof. Alright, first let them assume that a root 2 is a rational number. Alright, assume that root 2 is an irrational number from the basis. But we already know that root 2 is an irrational number, but we want to prove that it's an irrational number, alright? So per our proof, we can see that root 2 is an irrational number, alright? So since P and Q are even, we say that both have a common factor of 2. And that contradicts our initial assumption that P and Q have no common factors other than 1. Alright, so that contradicts our assumption from the initial stage. Alright, and therefore we can say that the initial assumption that root 2 is rational must be false. It must be false. And then we say that root 2 is an irrational number, not a rational number. Therefore, proven or hence proven as required. Thank you very much for watching this video. I really appreciate all of you. My viewers, please don't forget to subscribe, share to others to also benefit. All right, thank you very much. Bye.